Okay, so hello everyone. This is Yi here, and this is another series of group mentoring and training videos. And today, the topic we're going to be focusing on is how to create good figures. So, figures are definitely one of the most important components as you start preparing to write your first journal publication. Right, so good figures really helps with the scientific publication a lot. If your reviewer are able to grasp the main idea of your paper just by looking at the figures, it really just increase the chance of the paper being accepted dramatically. Right, so that's one of the reasons why we need to learn about how to do good figure works. So the purpose of this video is I really hope to create a kind of like a standard operating procedure type of workflow to build good figures, decent looking good figures. And the two goals is one, I'm not gonna use any advanced software, and two, I hope that this is the strategy I'm sharing with you. It's understandable, even if you're a STEM student, you're engineering or science student, that you've never done any design in your life, so you have zero design or drawing background. You're still going to be benefits from the technique I'm going to be sharing with you here. So for that, I'm only going to be using the PowerPoint and Excel. So most likely, your university already provides you with the free access to these two softwares. Many universities actually don't provide student free access to, say, more advanced softwares like Adobe Illustrator or Photoshop. At this my university don't. So and hopefully without those advanced software, we can still with the help of this information shared in this series of videos, you could still use PowerPoint and Excel to create very good figures that help you with your publication. All right. So let's get started. To talk about the figures, we want to first go over what's good figures. I think one of the key concepts here is that the figures are used to convey information. So like we've already discussed, if the reviewer are able to grasp the overall idea of your paper by just looking at the figures, that really just helps them to appreciate your novelty and also helps them to make up the decision to accept your work. So for instance, on the left, I'm showing you one of my paper published last year in Nature Communication. So this is the first figure, and the goal is to talk about sell our stories, right? Sell to the readers and also the reviewers why our work is good. What's the novelty of the proposed work? So this paper is about modular and uniformly thick origami inspired structures. So mutoids, that's the name that we create for it. And this figure, subfigure F, is basically comparing our created system with all the rest of the other system that you can find in the literature for the civil application. So at the bottom, we're talking about deployable shelters, bridges, modular buildings, space structures. They typically have less than two configurations. And the space-oriented, the structures using space, they typically have larger packaging ratio, but they just don't offer a lot of shape versatility, less than two shapes, typically. Our work, we're targeting more than two shapes with decent packaging ratio, and that's usually only found in metamorphic mechanisms, but these mechanisms really aren't very good at taking load. So that's the main story we want to sell. So a figure like this is usually correlated to, I would say, 3, 4 paragraph of information, and it's a condensed version of those condensed information that really helps the reader to get the main concept, and that's very helpful. So of course, in order for these figures to sell to the readers and also to the reviewers, you need to make sure that everything is readable. We have the correct font size, the color selection is good. You have secondary, let's say the different types of lines that you're using to help color-blinded people increase the accessibility of this figure work, and also using the correct and nice line widths that's making the figure good looking. All right, so these are components we're going to cover um, in the following video. So let me move we don't need organization here. Let me move myself around a little. So the organization of these series of videos is really going to be like the right-hand side. So in the first video, which is this one, what we're going to be doing is we're going to talk about some of the basic composition of a complex figure, right? So for instance, the left-hand side is a figure that is a full page wide. It's made up with seven uh, sub-figures. So it's how do we composite a figure like that? So the video two, we're going to be focusing on building charts. So we're talking about these line charts. We could be talking about force displacement curves, force strain curves, a relationship between, several variables. It's very common in research about structures, active structures, metamaterials, the Young's modulus, right? That's how people show their experimental result, and I'm pretty sure it's also very popular in other disciplines. So that's going to be the focus of the second video. And in the third video, we're going to be talking about building illustrations. So this figures that shows the readers how we're actually implementing this experiment. So this is a 3-point bending test. How can we draw a figure like these in Excel? This is an Excel task. How to draw it. It's actually much simpler than you might imagine. Sorry, not in Excel, in PowerPoint. So PowerPoint is actually very good at drawing these figures, illustrations. And then finally, in the figure 4, I do hope to go through a case study, which is one of a recent paper I'm working on right now, and really want to share with you how I spot some communication problem during the review process, and also um, address some of the comment from the reviewer through creating good figure works. All right, so let's start talking about the typical composition of these complex figures. Let me move myself to here. All right, so the left-hand side is a typical double column journal paper. So whether it's an A4 or letter size, it actually kind of doesn't matter. So the width of the A4 paper is 210 millimeter. For letter is 8.5 inch or 216 millimeter. They're relatively close. Not a big difference there. No big difference there, really. And then when you are composing your figures, you really want to keep the width in your mind. That really helps you to determine how I want my subfigure to look like. So for instance, if I want a figure with a width of the entire page, so if it's A4, then we're talking approximately 7.5 inch, right? Because you do need to take out, let's say, 0.1, 0.2 inch of white space on the left and the right. So that's the width of your figure, about 7.5 inch-ish. Then if you have each of the subfigure to be occupying 1/3 of the total width, we're talking about 2.5 inch or 7.5 centimeter wide per this subfigure. And if you want to break up your full width figure into 4 subfigures, each one of them will be about 2 inch wide, the subfigure, or 5 centimeters. So the left figure you're seeing here is actually using that composition. So we can see that at the bottom, it's clearly 4 figures. It's of course not fixed, right? So the figure G, subfigure G here is like it's extending top and down, and then the subfigure A is like wider than a quarter, but then subfigure B and E is like shorter than a quarter, so it makes up the space. And you can try to move things around to make sure that they fit. But overall, if you have this in your mind while you're drawing the figures, it really helps you to make your figure looks much better, um, during the publication, and sometimes even save you money. Because if you don't do this very well, if you have a figure that's very awkward, it does not fit into a full page wide or a half page wide, if neither of those fit your figure, it might be awkwardly placed as a full page wide figure, but have, let's say, 2 inch of white space on both sides, and then it will make sure article to be extremely long, and you need to pay the extra fees because you exceed the page limits. So that happens occasionally. So good figure works actually also could help you to save money during the publication. All right, so let's talk about how we can create this composition here, and we're gonna, like I promised, everything will be in PowerPoint or Excel. All right, so let's start with a full page wide layout. So how can we do it? Um, let's see. Let's say this is typically a blank template from Excel. That's not gonna work. So what we want to do is we want to go in here, go to the Design tab, and then on the top right, there's this slide size. Go to the Custom Slide Size, and let's do the letter paper, and then let's get it to portrait. So the width is already taking out 1 inch of white space on both sides. That's half an inch on each side, that is. So that's actually a little bit larger than what typical journals would do. So let's actually keep the width to be 8 inch here. So this is about 0.2 inch white space on both sides. So that's a good size to have. So just clicking width is actually the only thing that matters here. So we don't care about this. And let's say what I want to do is I have a lot of figures like this one shown this line chart from Excel. Let's say it is one specimen. So I'm doing, I don't know, perhaps a bending test of a reinforced concrete specimen. And I have 4 specimens with different aspect ratio I want to show. So this is one of them. And how can I lay this 4 figure on my full page template I just created, right? So let's do that. So let's say I have 4. So well, actually, let me first adjust each of these. Um, we can right click this chart that I just copied from Excel. So if you're working using Excel and PowerPoint, they actually align with each other smoothly. I can right click and format chart area. I can actually change the let me move myself here. The size of each of these figure to be let's say 2 inch by 2 inch, and then I have a 2 inch wide figure. So the font size is not good at this point because it's larger than what you typically have in a 2-column journal publication. So what I would recommend you to do is change the font into, say, Calibri or Times New Roman. That's 2 very typical font that's being used in the publication, but make sure the size is 8 point. And you can make the figure all have black text color, and you can bold, force, and displacement actually helps to make it clear. So the reason why I set the font size to be 8 is because I will copy paste this figure to the to another Excel, excuse me, to another Word document later, and you will see that it actually matches what a Word would look like, let's say, in a scientific publication setting. So, like we've previously discussed, we want this to have four segment, right? This could be from different data. Actually, let us do that. Let's get another data so that not everything is the same, right? All right, get another data and change the height to be 2 inch by 2 inch. And again, Times New Roman, 8, bold, only bold this part and this part. All right, all right, all right. So that's very easy, right? You now have four figures that are nicely uh, spaced, evenly spaced with nice font size that matches with each other, and they're equally spaced along the width of your page. And the next thing you can do is really just start adding in these subfigure A, B, C, D to indicate that you have this full part. So this one you can actually use a larger font size, a little bit larger, and you can bold it to make it clear, right? And then this is gonna be B, this is gonna be C, and then this is gonna be D. So let's do that. Right? Very straightforward, right? Now you have a figure that's mostly ready. The final thing we want to do is to just adjust the height of the page. So we can go to the design page and again change the size of the slide. So because we already know that every subfigure is like 2 inch height, it's just clicking 2 inch and then click OK. Um, and we can click maximize. It's gonna, you probably will need to move things a little bit, but it will fit perfectly here, just like that. Look at that. We have a very nice figure already. And then if I save as a PDF file, so PDF file actually keeps everything to be a vector graph. So you can zoom in like 100 times larger and it's smooth. It's not gonna show that zigzag curve like what you have. Yeah, that's what I'm talking about. You can zoom in a lot and the curves are still gonna be very sharp. It's not like a bitmap. So a figure like these, you can include that into the papers, right? It will look nice there. Um, oops. Insert pictures, this device. I think I should be able to insert a bigger work. Uh, I do want to get okay. All right, so it does looks like Words does not support PDF. LaTeX do support it, so if you're writing in LaTeX, it doesn't matter, but here's a trick. You can use the snipping tool. So just search for the snipping tool and make sure your figure is displayed very large, and then you can create a snipping figure of it, and then just save this figure as your um, as a PNG file, and that will allow you to include that into the Word document. So let's see. There we are. So I do want to make sure that this is a full page wide figure, right? So that's the result that we're getting. And two things I want you to pay attention to. The first is that as you can see that if you make sure that you zoom out, zooming into the figure while you're taking the snipping figure, it's going to be clear enough for most of the, um, let's say, pre-publication um, figure work. For manuscript for review, this is going to be clear enough. For your final submission, they typically want you to submit a vector graph, so the PDF is the nice option in that case. And then the other thing is just notice like how these font size in the figure actually matches that from the text. That's actually very important, and that's one of the things that will makes you get a good looking published figure. So I can show you some of the published papers, and you can compare that with what we've just got, right? So the in the two column words setup, the font is usually like 9 in the main text. So you can see that this 9-point font actually matches this uh, niche communication paper pretty well. It's actually not just this. As a matter of fact, so this is small. Most of the papers have relatively similar font size. It's either 9 or 10 or 9.5-ish in the Word. So I can open another two-column paper. You can see this looks like 9.5, a little bit larger than the left, but that's what it is, right? So if you follow the sizing and the font size I talked about previously, you are able to get the figures to the text on the figures to match the text in your main article relatively well, and that will enable that you get a good looking figure. All right, so the next thing I want to do is go back here because we just talked about the full width um, figure. We can also do a half page wide figure. So again, we start with a blank Excel template, and you probably already know what we're going to be doing here, right? So custom slide width. So the letter size is 8.5 by 11 inch, and we're going to have a portrait. And then because journal publication typically have about 0.5 inch of white space both sides, so one column is approximately 4 inch in the width. Just do fours. Just put a 4 here and you're good. And for this particular figure, I think I will have approximately 4.5 or also like a 4 inch height. So I can directly create it, maximize. And what I want to do is I want to put two figures like that, side by side. And let's directly make use of the work we've already done before, right? So, oops, this one. So again, let's imagine that we're doing an experiment with Let's first align them. Okay, that looks very aligned. So let's assume that we're doing an experiment of, let's say, a reinforced concrete beam, right? And then I just want to use this top space to create a illustration. Um, it's reinforced concrete, so it's going to be grayish color. And usually your figure will look better if you use a thinner line. And this will most likely be some sort of a 3-point bending test. So this is probably a metal block. I can use this color coding to indicate a metal block. And again, thinner. Actually, let me put everything to be very dark here. And then we will have a circle with the same color. And then here, so there's usually a steel plate behind before you put the beam onto any sort of a roller or fixed support, right? So in this side, we can put the triangle indicating that this side is not allowed to move in the axial direction of the beam. Right, so that's I have drawing like that, and this will become my part A. Right, so now what I can do is I can start marking. I can right click send to back so that I can get access to the item in the front. All right, so that's I can now start adding in. This is um, load, and let's say we put 20 kilonewton of forces at the top. So again, whenever you're doing text, if you're using Times New Roman, then keep everything to be Times New Roman, and you can bold it here, right? And I can put an arrow here indicating that the force is coming from here, right? So you can start pulling in this text to help convey information. And then I can also say cracks start forming at the bottom, right? So just follow the font size and either use Times New Roman or Calibri, just use the two, um, and you're gonna be in good shapes. And then in the shape, if you're drawing here, uh, you can actually start drawing some scribble to indicate a crack. That's actually going to be super fun. It's actually not that hard, honestly. Um, right. So yeah, and then change the width of the line until they looks good to you. This looks pretty good. Right. So now I have a pretty descriptive figure, right? So everyone sees, they kind of know, oh, I'm doing some sort of a testing for a reinforced concrete beam. There's going to be cracks forming. And if the cracks are corresponding to, say, a specific point on your chart, you can always put, this kind of circle here to just tell the reader, okay, this is where the cracks are forming, right? That makes everything very clear. And then you can next, if you want to do things, you just want to make things looks good. I think the width looks like it's 3.6-ish. So let's go to the design page and change the slide height to fit what we just draw. I think I can make it a little bit more tighter. 3.4 seems to be enough. Just click maximize when you do that. um, change. Okay, there we are, right? It's about right. And this would be a very good figure. So again, if you need a vector graph, you can use save as and save as a PDF. That's usually some, that's a format that LaTeX and your final submission, you can use in final submission. If you are using Word for your main manuscript, you could always use the snipping tool. Just make sure that you're blow up the figure to occupy your entire screen before you take a snipped PDF figure of that, because you do want high resolution. And boom, there we are, right? So let's see what it looks like in a journal kind of picture here. So I have a second figure here, right? Look at that. Isn't that very good looking, right? It's you just need to follow these dimensions and your figure will just blend into the two-column journal publication perfectly, right? So the font size matches what people would expect, and it matches the font of the manuscript nicely, and it blends into this two-column paper just seamlessly. And if you start typing, let's say behind it, figure one, blah 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 blah, it will look very nice. Your Yeah, so then just make it bold, right? It almost looks like a final publication, right? Everything looks good. So if you can take into the composition into your consideration when you're building these complex figures, it really makes the figure looks good when they're published. So this is one of the key takeaway of the first videos. So I'm gonna end here, and in the next video, what we're gonna be talking about is building chart. All right, thank you very much for your attention, and have a great rest of your day.